Hello and welcome back to another Walking Talking mock. This is May 2005 C3 Old Spec A2 Maths, and this is section B. I already did section A, so check for that. I was going to say I'll leave a link in the description box, but you know what, I'm not going to because I'm not a proper YouTuber. So, question 8 says, Figure 8 shows part of the curve y equals x sine 3x. It crosses the x-axis at P. The point on the curve with x-coordinate pi over 6 is Q. Find the x-coordinate of P. Okay, so it's where y equals 0. So if our equation is x sine 3x, and I want that to equal 0, then obviously x equals 0 is one solution, but that's that one, so that's not the one I want. But the other solution will be sine 3x equals 0. Now if I just do the inverse sine of 0 in my calculator, it's going to very unhelpfully just give me the answer 0. So I have to think more carefully about a sine curve. So a sine curve will equal 0 in lots of places. The first one is 0, the second one is pi, or 180 degrees. But this is, so I can say that 3x equals pi, so x equals pi over 3. But, I mean, there are infinitely many answers, of course, but P is the answer that's after 0, so that's why I'm choosing pi. If this curve kept going, then I'd have other answers as well. So P is pi over 3 is 0. And then, oh, it just said x coordinate, so I don't need to write that. Part 2, show that Q lies on the line y equals x. Okay, Q is where it's pi over 6. Okay, y equals pi over 6. Let's substitute the x value in. Okay, which sine of 3 pi over 6, that's a half. Sine of a half of pi, I mean, half of pi is 90. Sine of 90 is 1. Okay, so that equals pi over 6 times 1, which equals pi over 6. Oh, so the x-coordinate and the y-coordinate are the same. So it lies on the line y equals x. Okay. Part 3. Differentiate x sine 3x, hence prove that the line y equals x touches the curve at Q. Okay, so if y equals x sine 3x, it's a product, so I'm going to use product rule. U equals x, v equals sine 3x, du by dx equals 1, dv by dx equals cos 3x times 3. You thought I forgot the 3 then. Don't worry. Do not worry. dy by dx equals v du by dx plus u dv by dx. Can't really simplify it. Hence prove that the line y equals x touches the curve at Q. So it's trying to tell me that y equals x is a tangent. That must be what it means, right? It is a tangent to the curve at Q. If it touches it rather than bounces, what was I saying? Rather than like cuts through it, then it must be a tangent. So what's the gradient of y equals x? 1. So I need this to have a gradient of 1 at Q. Okay, so at Q, dy by dx will equal sine of 3 pi over 6 plus 3 pi over 6 cos of 3 pi over 6. Substituting the x value of Q in there. Okay, so sine of a half is 1, cos of a half is 0. I better put plus 0 just to show that I know. Equals 1. Same gradient as y equals x, therefore touches at Q. Okay. I can't fit next question on, so let's put that to the side. Part 4. Show that the area of the region, I should show you these. Show that the area of the region bounded by the curve and the line y equals x is this. Okay, let's draw it. That's a terrible picture. Okay, let's draw the line y equals x. Okay, so area of the region bounded by the curve and the line y equals x. The way that my picture is, there does not appear to be a region bound by that. So I think it's supposed to be like here, but in my drawing you can't really see that. Something like that. Okay, but anyway, let's find the area under the curve just to start with. So I want the integral of x sine 3x dx, and I need it to go as far as Q, right? Yeah, okay. So what was Q again? Pi over 6. So 0 to pi over 6 of that. It's a product, so I should probably do integration by parts. Also, I haven't done that yet this exam, so I feel like it's due, yeah? Okay, integration by parts. uv minus v. Okay, so let u equal, and then let dv by dx equal. Which one would be easier? Well, whether I differentiate or integrate this makes no difference, because either way it's going to be a cos. But if I differentiate that, it becomes quite simple. So I feel like that should be the thing that I differentiate. That's how I decide, by the way, which way round I do things. I think if I integrate it, would it make it easier? If I differentiate it, would it make it easier? So that one's 1. Integral of that is a third cos 3x, except it might be negative. Let me think. Yeah, it's going to be negative, isn't it? Okay, so let's just bracket that off so I can write equals uv minus integral of v du by dx. V du by dx. Okay, minus I tell you what, I'm going to put the minus there and the third there, just to make my life easier. And the limits need to go here. Well, and I should really put some limits on this bit as well. But that bit's already been integrated, so that's going to have like square bracket type limits instead. That makes sense? Okay. Let's just leave that bit as it is for now. Let me integrate this. Integrate cos, I get sine, yeah, so I'm going to get a third, so a ninth now, of sine 3x, and the sign does not change. And let's put the limits. Okay, and now let's substitute. So that's minus pi over 18 cos of pi over 2 plus a ninth of sine of pi over 2 minus, that will become 0, and that will also become 0. So what's cos of pi over 2? It's 0. And sine of pi over 2 is 1, so that's just a ninth. Very nice. Okay, so but that's the triangle. Not sorry, what am I talking about? That's not a triangle. That's this. That's that thing. But what I actually wanted was this bit, the area between the curve and the line. Okay, so I'm going to have to find the area of this triangle and then subtract the pink bit. So, area of triangle. Half base times height. Half times, what's the base of that? That's going to be pi over 6, because the x-coordinate of Q is pi over 6. And the y-coordinate was also pi over 6, wasn't it? So it's half of that square. So that's pi over 72, I want to say. Oh, sorry, pi squared. Sorry. So, what's the word I'm looking for? Required area equals pi squared over 72 minus a ninth. I've just realised the answer actually is given in the question, which is nice, and it's in that format, so I'll just say which equals that. Which it does, right? Because, yeah, a ninth is the same as 8 over 72. Yeah. Cool. So let's mark this. I better go back to the beginning. Part 1, we get M1 for, what, just equating it to 0? Why are we getting a mark for that? It's a bit easy. Accuracy 1 for pi, or 180. And accuracy 1 for pi over 3, but not 60. Okay, so they're going to be lenient for this accuracy mark, but they're going to be strict for this one. Okay, then we get E1 for basically question 2. Just showing that the gradient is the same. It says must conclude in radians and be exact. So you have to have used radians to get the answer. In fact, if you don't use radians, you won't get the right answer anyway, because if you substitute 60 degrees into this, your answer would not actually work. Actually, you know what? I think it would. Never mind. This bit, this line here is very important as well. Got to have that. Okay, part 3. B1 for knowing that when you differentiate sine 3x, you get 3 cos 3x. So you get B1 for that. Product rule, we're going to get M1 for using the product rule. And it just has to be consistent with your derivatives that you got here. So if you got those two wrong, you can still get this method mark. You get accuracy 1 for the answer, which is that. You get M1 for substituting, and then you get accuracy 1 for getting 1, which is a follow through, as long as you got the first method mark. And then you get E1 for saying it's got the same gradient as y equals x, so it touches at Q. And then part 4, you get method 1 for using integration by parts, and you get accuracy 1 for getting this line here. You get accuracy 1 follow through for no, you know what, you get accuracy 1 for that line, and then accuracy 1 for that line, and it's follow through for this one, but this one's correct answer only. You get M1 for doing the limits, and then you get accuracy 1 for the answer. You get B1 for the area of a triangle. B stands for basic, if I didn't already say that. And then you get E1 for coming to the correct answer. And it's an E because they told you what the answer was in the question. Okay. On to question 9. And this is the last question? Question mark? Yeah, it's the last question. So, the function f of x equals log of 1 plus x squared has the domain minus 3 to 3. The graph shows it. Show algebraically that the function is even. State how this property relates to the shape of the curve. Well, you know what? They gave you the curve, so you should know, you should at least be able to answer that. Okay, show that it's even. So f of x equals log of 1 plus x squared. So to show that it's even, we're going to substitute minus x into it. Like that. And of course that minus x squared is actually equal to x squared. So that is equal to that, which is the same as the original function. Therefore, it's an even function. And state how the property relates to the shape. It is symmetrical, as we can see, about the y-axis. Okay. Part 2. Find the gradient of the curve at the point 2 log 5. Okay, so let's differentiate it. Log of 1 plus x squared. I'm going to use a bit of chain rule here, so I'm going to differentiate log of blah, which is 1 over blah. And I'm going to times that by the derivative of the blah, which is 2x. At 2 log 5. So f dashed of 2 is 4 over 5. Okay, that's quite nice, 4 marks. Explain why the function does not have an inverse for the domain of minus 3 to 3. Okay, well I can see from this picture that if it did have an inverse, well, this function is a many to one function, and many to one is okay as a function. But if I inverted that, it would be one to many. And if it's one to many, it's not a function, because functions have to be something to one. So I'll just have to say that. In this particular domain, I suppose I should say. So this function is many to one. Because if it was in a smaller domain, right, if I cut the domain to just this bit, then it would be fine because it's one to one and I can invert that. So it's many to one in this domain, therefore inverse would be one to many, therefore not a function. So yeah, does not exist. Where am I? Okay, so the domain of f of x is now restricted to what I just said, okay, and the inverse of f of x is going to be called g of x. Sketch those curves on the same axes, okay. So we got something like that is f of x. And I'm going to have to do a y equals x line, which I will label, because if I draw it terribly, I want them to at least know that I tried, you know, I want them to know I had the correct intentions. Because, you know, you will be marked for your intentions, as long as the examiner knows what your intentions are. So now I'm going to invert this, so I'm going to symmetrize it. Yeah, the word is reflect. Okay, I'm going to reflect it like that. G of x. You know, and if you are one of these people who's just really bad at drawing, it might even be worth writing here, like, I attempted to reflect this in the line y equals x. Because then they know what your intention was. Okay, what else did I have to do? Draw it on the same axes, state the domain. Wait, where am I reading this? State the domain of g of x. Okay. So the domain of g of x is the range of f of x, because that's how that works. Let me just jot down f of x. The domain was -3 to 3. Okay, so the range of f of x, is it obvious from the picture? Not really. I mean, it's obvious it starts from 0, so I can put that in. Okay, but the maximum is where 3 is, so if I just sub 3 into here, so that's log 10. So the range is from 0 to log 10. So for g of x, then, it's going to be the exact opposite. Oh wait, hang on. I wrote this wrong. We restricted this, didn't we? To 0. Okay, so the domain is going to be 0 to log 10. And the range is going to be 0 to 3. Okay, I only wanted the domain, but I just felt like doing that. Notice how domain, you write it in terms of x, and range, you write it in terms of f of x. Or you could write it in terms of y if your function was given as y equals. And I did the same for g of x here. Okay. Where am I at? show that g of x equals that. Okay, basically find the inverse of f of x. So y equals log of 1 plus x squared. I'm going to find the inverse, so I'm going to swap the x and the y over. So x equals log of 1 plus y squared. So e to the power of x equals 1 plus y squared. So e to the x minus 1 equals y squared. And because it's a function, I'm going to have to just make it the positive square root. Because if it was the negative square root as well, like if it was plus or minus, it wouldn't be a function because it would be 1 to many. So we're just going to do that. And that is shown. Okay, part 5. Differentiate g of x, hence verify that g dashed of log 5 is 1 1/4. Explain the connection between this result and answer part 2. Okay, so g of x was root e to the x minus 1. G dashed of x equals, you know what, I have to write this as this because I just can't. Whoops. Don't know why I put a minus there. Okay, so I'm going to chain rule this. So I'm going to differentiate bl to the power of a half, which is a half bl to the power of minus a half. And I'm going to times that by the derivative of the bl, which is e to the x. That looks a bit ugly, but I think I'm just going to leave it as it is. I can't really make it look any prettier than that. So, yeah, I guess let's just maybe put e to the x over 2 e to the x minus 1 to the half, or I could put a square root, I don't know. Yeah, that's nice enough. Okay, hence verify that g dash of log 5, okay, g dash of log 5 equals e to the log 5 over 2 e to the log 5 minus 1 to the half. E to the log 5 is just 5. And e to the log 5 is 5. 5 take away 1 is 4. Square root of 4 is 2. 2 times 2 is 4. Equals 1 1/4. Okay. Explain the connection between this result and your answer from part 2. So in part 2, at 2 log 5, f dash of 2 is 4/5. Okay, let me write this down. Okay. At 2 log 5, f dash of 2 is 4/5. At here the x coordinate is log 5. Because g of x is the inverse of f of x, if the x coordinate is log 5, the y coordinate will be 2. It's the opposite way around because you've switched the x and y around. And the gradient at that x value is the same, but it's swapped around, it's reciprocaled. And I'm just going to write there, reciprocal. That's my way of explaining the relationship. Is that it? Yeah, that's it. Okay, let's mark that question. Let's find the answers. Okay. M1 for putting minus x in. And then, sorry, that looks confusing, doesn't it? There we go. And E1 for saying equals f of x, therefore even. And B1 for symmetrical about y-axis. It says you can accept reflects in the y-axis, but that sounds stupid, so don't write that, please. Okay, part 2, M1 for using chain rule, either explicitly by writing like, you know, u equals this, or just by doing it in your head. Accuracy, nope. B1 for the fact that when you differentiate log, you get 1 over, seen or implied. Mine is implied because I did it in my head. I'm so clever. Accuracy 1 for 2x over 1 plus x squared, and accuracy 1 for 4/5. B1 for saying that it's not 1-to-1, so it won't have an inverse, or it's many to 1, so it won't have an inverse, something like that. Just as long as you refer to the something to something. I'm going to get M1 by attempting to reflect. I'm going to get A1 for reasonable shape and domain, i.e. no negative x values, an inflection shown, okay, I've got kind of a lump there, does not cross y equals x line. Yeah, mine does not cross the y equals x line. Right, kind of does there, but that's fine. Okay, and then domain, okay, 0 to log 10, that's a B1. And it says it's okay if you've put y instead of x here. I think that's a bit dodgy, but fair enough. M1 for this switcheroo. M1 for taking the E, for doing the E thing. The box rule, I think some of you call it. Which I think is stupid, but fair enough. And then E1 for... what? Oh, E1 for the answer. Ooh. Yeah, sorry, they've got an alternative method on there, which is a bit weird. Right. Part 5. B1 for having like a half of something to the minus half. Did I put the half? Yeah, I did put the half. I did put the half, don't worry. Don't worry. Okay, B1 for timesing it by e to the x, which I did. M1 for substituting log 5. Must be some evidence of substitution. That's because the answer was given to you, so there's got to be evidence of substitution to get your E mark. And then B1 for this, the notes say must have idea of reciprocal, not inverse. So yeah, you've got to mention the reciprocalness of it. And yes, that is the whole of that paper. I didn't think that was too bad as far as papers go. For me, the difficult question on C3 is always the integration question, where it asks for a weird area. But the weird area it asked for in this paper was not really that weird. Like, the subtraction was kind of like, it was easy enough to see. It's not always. So yeah, thank you very much for watching, and happy revising. I'll see you next time. Bye.